Hi students, I am Raghavan, chemistry faculty from ALPHORES College. I welcome you all for ALPHORES chemistry e-learning classes, session 27th. So in the last session, that is 26th session, we were discussing about quantum numbers. Okay, so we had that introduction about magnetic quantum number. Magnetic quantum number. Okay, we have done this introduction completed. Magnetic quantum number was explained by Landé scientist. Landé discovered magnetic quantum number to explain Zeeman and Stark effects. Zeeman effect and Stark effects. Stark effect. Zeeman effect and Stark effects. Okay, what is that Zeeman effect? Splitting of fine spectral lines under the influence of magnetic field is called Zeeman effect, and splitting of fine spectral lines under the influence of electric field, that is called Stark effect. Okay, to explain Zeeman effect and Stark effect, Landé explained the new quantum number that is called magnetic quantum number. Yes, magnetic quantum number, it is denoted by the symbol M. Magnetic quantum number is denoted by M. This represents orientation of suborbit. This represents orientation of suborbit. Orientation of suborbit. That means subshell. Orientation of suborbit or subshell. Okay. The orientation values represents an orbitals. Okay, the orientation values represents an orbitals. The orientation values, that means M values, depends upon azimuthal quantum number value, that means L value, that is ranging from minus L to plus L including 0. This range of orientation values, okay, the total number of orientations, that is equals to 2L plus 1 values. 2L plus 1 values. This 2L plus 1 values indicates what? That indicates number of orbitals in a subshell. In a subshell. Yes. Once again, the magnetic quantum number is denoted by the symbol M. That represents what? That represents orientation of suborbit. Okay. So M values depends on azimuthal quantum number value. That means L values. So the M values are ranging from minus L to plus L including 0. The total number of orientations are equal to 2L plus 1. The total number of orientation values indicates what? The number of orbitals in a subshell. We should remember that, important. Okay. Number of orbitals in a subshell. Okay. Next, let us see, this is number of orbitals in a subshell. Now, number of orbitals in a shell. Number of orbitals in a shell. Number of orbitals in a shell, that is equal to n square. That is equal to n square. Number of orbitals in a shell, that is equal to n square. Number of orbitals in a subshell, that is equal to 2L plus 1. Okay. So this is some important information about magnetic quantum number. Right. Now let us work out some numericals. That is some examples on this. Let us work out some examples on this. Okay. Suppose when L is equals to 0, that is when L is equals to 0 means which subshell it is? L is equals to 0. When L is equals to 0, okay, that is nothing but S subshell. We know that S subshell. When L is equals to 0, what is the possible M value? M value is 0. Remember that. M value is 0. Okay. So value is 0. That means M values ranging from minus L to plus L including 0. That means minus 0, 0 plus 0. That means 0 only. So M value is 0. How many orientations are possible with this? Number of orientations. Number of orientations. Number of orientations. That is, as we know that number of orientations indicates what? Number of orbitals. Number of orbitals. Number of orientations means number of orbitals. That is equal to, what is the formula for that? That is 2L plus 1. 2L plus 1. Okay. So 2L plus 1. Apply for this. 2 into L value is 0. Okay. Plus 1. That is equals to 1 only. Okay. That means, it means any S subshell contains only one orbital. It means any S subshell contains only one orbital, Okay, one orbital means one box like this. So it may be 1s, 2s, 3s, 5s, 6s, whatever it is. Any S subshell, always they contain only one orbital. Okay. S subshell contains one orbital. S subshell. Let us write clearly. S subshell contains only one orbital. Okay. Like that. Next, this is example 1, first example. Let us take second example. L is equals to 1. L is equals to 1 means that subshell is nothing but P subshell. Okay, when L is equals to 1, that is P subshell. What are the possible M values? M values are ranging from minus 1, 0, plus 1. Okay, that means minus L2 plus L including 0. Okay, so what are the total orientation possibles? So M is equals to 2L plus 1, 2 into L value is 1, 2L plus 1, that is equals to 3. It means the subshell L is equals to 1, that means P subshell contains 3 P orbitals. P subshell contains 3 P orbitals. 3 P orbitals. 3 P orbitals. Okay, that is L is equals to 1. Okay, next. See, third example, let us consider L is equals to 2. L is equals to 2 means that is a D subshell. L is equals to 2 means that is a D subshell. So, what are the possible M values? M values are possible like minus 2, minus 1, 0, plus 1 and plus 2. Total how many values are there? 1, 2, 3, 4, 5. That means total M values are, that is 2L plus 1, 2 into L plus 1, 2 into 2 plus 1, that is equals to, remember, M values are always equal to 2L plus 1, okay, plus 1, that is equals to 2 to the 4 plus 1, 5. That means D subshell contains 5D orbitals. D subshell, it may be 3D, 4D, 5D, whatever it is. So, the D subshell always contains 5D orbitals. 5 orbitals. Okay. D subshell contains 5 orbitals. P subshell contains 3 orbitals. And S subshell contains only 1 orbital. Okay. You should remember that. One more. Let us take up one more. It is L is equals to 0. L is equals to 1. L is equals to 2. One more. Let us work on L is equals to 3. L is equals to 3 means that is nothing but F subshell. F subshell. This F subshell, the possible M values are minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. So total how many values are possible? So it is 7 values are possible. Okay, so therefore m values, total m values are 2l plus 1, 2 into l plus 1, 3 to the 6 plus 1, 7. That means F subshell contains 7 orbitals. F subshell contains 7 orbitals. Okay, that means number of orbitals present in a subshell, number of orbitals present in a subshell, that is equals to 2l plus 1. Okay, this is about magnetic quantum number. Okay, once again, magnetic quantum number signifies to explain orientation of suborbit. Orientation of suborbit. That means this magnetic quantum number explains existence of orbitals in the subshell. Okay, that is orbital. In other words, we can also call it as subshell. Okay, shell, subshell, subshell, orbit, subshell, orbit, subshell and subshell. Okay, that is magnetic quantum number. Next one is spin quantum number. Landé discovered the magnetic quantum number to explain Zeeman effect and Stark effects. Zeeman and Stark effects. Okay, what is mean by Zeeman effect? Splitting of fine spectral lines under the influence of magnetic field is called Zeeman effect, and splitting of fine spectral lines under the influence of electric field is called Stark effect. Okay, so to explain Zeeman effect and Stark effect, Landé proposed a new quantum number, that is magnetic quantum number. So according to the magnetic quantum number, so magnetic quantum number values depends upon azimuthal quantum number values. So that means m values depends on l values. Okay, so these values are ranging from minus l to plus l including 0. The total number of orientation values are equal to 2l plus 1. Okay, each orientation value represents orbital. Okay, each orientation value indicates orbital. So now the magnetic quantum number explains existing of orbitals in the subshell. Existing of orbitals in the subshell. Yes. Now coming to the spin quantum number. Spin quantum number. The spin quantum number was explained by Uhlenbeck and Goudsmit. And Uhlenbeck. Uhlenbeck and Goudsmit, they explained spin quantum number. Okay, this spin quantum number signifies to explain. The spin quantum number signifies to explain. It is denoted by the symbol S. Spin quantum number is given by the symbol S. This S represents what? This S represents direction of spin of electron. Spin quantum number signifies to explain direction of spin of the electron. Direction of spin of the electron. Okay, what is the direction of the spin of the electron? Suppose if the electron is like this, then the electron rotates, say for example, the electron rotates clockwise. The electron is rotating clockwise. Okay, so it is clockwise spin. Clockwise spin. So for that electron, the arrow mark is representing upward. So this electron, the spin quantum number value is plus 1 by 2. Plus 1 by 2. If the electron rotates anti-clockwise, if the electron rotates anti-clockwise. Rotates anti-clockwise, okay, that is anti-clockwise electron. Anti-clockwise electron, that is represented arrow mark downward, okay. So this given the spin quantum number value as -1/2. Clockwise spin electron is plus of anti-clockwise spin electron is given -1/2. So for a stable orbital, to represent a stable orbital, so the two electrons in the orbital should have opposite spins. The two electrons in the orbital, so they must have opposite spin values. So the two electrons of orbital must have opposite spin, that is plus half and minus half, okay. Now the angular spin of the electron in the orbital is given by, that is angular spin moment of the electron in the orbital is given by h/2 pi. Spin momentum of the electron is equals to, that is h/2 pi into under root s into s plus 1, okay, that represents spin momentum of the electron, okay. So the spin quantum number signifies what? Spin quantum number is given by s. What does it represents? Spin quantum number represents or signifies to explain direction of spin of the electron, okay. If the electron rotates clockwise spin, its spin value is given plus half, plus 1/2, and if the electron spins anti-clockwise, so that is given by this arrow downward, and spin value is given -1/2, okay, -1/2. And another point you should remember this. So among all the four quantum numbers, so principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number, okay, the quantum number which cannot be derived from Schrodinger wave equation is the spin quantum number, okay. That is one of the important bit, okay. So that is about spin quantum number. Let us describe the significance of all four quantum numbers once again, okay. Let us see the significance of all four quantum numbers, that is shortcuts, significance and examination point bits, okay, right. Let us see principal quantum number. Principal quantum number, yes, principal quantum number, it is denoted by the symbol n, okay. N values, that means number of orbits, are 1, 2, 3, 4, so on, are k, l, m, n orbits, okay. And significance of this principal quantum number. Significance of principal quantum number, that is, it explains size. It explains size and energy. It explains size and energy. Yes, principal quantum number signifies to explain size and energy. So that means principal quantum number was explained by Niels Bohr. He explained the equations to calculate size and energy, okay. So that is the significance of principal quantum number. Next one is azimuthal quantum number. Second one is azimuthal quantum number, okay. This azimuthal quantum number was explained by Sommerfeld, okay. This azimuthal quantum number is denoted by the symbol L, okay. That what does L represents? L represents existing of suborbit. Suborbit means subshell, or you can say sub-energy level. Okay, according to Sommerfeld, elliptical suborbits are existed in addition to the circular suborbits in a given energy level. Okay, very good. So how many suborbits are existed in a given energy level? How many suborbit means how many subshells are existed in the given energy level? So the number of suborbits existed in a given energy level equal to n value. Should remember that. So L values always depends on principal quantum number, that is equals to n minus 1. N minus 1. That means L values starts from 0, 1, 2, 3 and so on. Okay, what are these values represents? These values represents suborbits or subshell. That means sub-energy level. Okay, that is SPDF subshells. SPDF subshells. Okay, 0 S subshell, 1 P subshell, 2 D subshell, 3 F subshell. They represent subshells. Okay, then maximum number of subshells, maximum number of subshells exist in an orbit. In an orbit, how many subshells are existed in the given energy level? That means in an orbit, that is equal to n value. That is equals to n value. For example, in first orbit, how many subshells are existed? Only one, because n equal to n, that is nothing but L is equals to 0. So that is second orbit. Let us say some examples based on this. Okay, nucleus, first orbit, second orbit, third orbit, okay, and fourth orbit. Let us take n is equals to 1, n is equals to 2, n is equals to 3, n is equals to 4. Yes, in first orbit, how many subshells are existed? 0, that is nothing but S subshell. That is nothing but S subshell. In second orbit, 2 subshells are existed, that is 0 and 1, that is S and P subshells are existed. And third orbit, 3 subshells are existed. What are they? 0, 1 and 2. 0 means that is S subshell, 1 means that is P subshell, 3 means that is D subshell. And in fourth orbit, how many subshells are existed? It should be 4 only. So 0 subshell, 1 subshell, 2 subshell and 3 subshell. 0 means that is S subshell, P subshell, D subshell, F subshell. These are the subshells. These are the subshells. Okay, these are the subshell values. Okay, so that is maximum number of subshells exist in an orbit. In third orbit, how many subshells are existed? 3 subshells. Okay, and another point you should remember. So the number of, that is L values must be less than N values. Suppose N is equals to 3. What are the possible L values? It should be less than N. That means less than 3. That means 2, 1, 0 are possible. Okay. Yes, like this. Maximum number of subshells exist in an orbit is equals to N value. Okay. That is azimuthal quantum number, right? Now, azimuthal quantum number significance, let us say. Azimuthal quantum number signifies to explain existing of subshells and their shape. Significance of azimuthal quantum number. Significance of azimuthal quantum number. It signifies to explain existing of subshells. Subshell, that means suborbit, subshell and shape, that is given by azimuthal quantum number. And one more point in this, orbital angular momentum. Okay, that is azimuthal quantum number only. Orbital angular momentum. or that is angular momentum of the electron in the orbital. Angular momentum of the electron in the orbital, that is orbital angular momentum. Angular momentum of electron in an orbital that is equal to h by 2 pi into under root L into L plus 1, important, okay, where L is equals to what? Subshell value, okay. For suppose if it is S subshell, L is equals to 0, P subshell, L is equals to 1, D subshell, L is equals to 2, and F subshell, L is equals to 3, okay. Or that is angular momentum of the electron in an orbital is represented like this, okay. That is azimuthal quantum number, we can explain, right. This is about azimuthal quantum number, right. Next, coming to the magnetic quantum number. Third one is magnetic quantum number. Magnetic quantum number, yes, magnetic quantum number is given by the scientist Lande to explain Zeeman effect and Stark effects, okay, that we explained already, okay. This magnetic quantum number is given by the symbol M. What does magnetic quantum number represents? It represents orientation of suborbit, okay, orientation of suborbit in the space, that is in the three-dimensional space, okay. So that M value depends upon azimuthal quantum number value. M value depends upon azimuthal quantum number value. These values are ranging from minus L to plus L, including 0. Minus L to plus L, including 0. The total number of orientations are M is equals to 2L plus 1. The total number of orientations are 2L plus 1, okay. The total number of orientations are 2L plus 1. Indicates what? 2L plus 1 indicates the number of orbitals present in a subshell. Remember, this M indicates what? Orientation of suborbit. What does orientation of suborbit? That what is the values? So each value significant to represent an orbital. So therefore each value represents orbital, okay. So M is equals to 2L plus 1. This 2L plus 1 indicates what? Total number of orientations. That means the total number of orbitals present in the subshell. Total number of orbitals present in the subshell, that is given by 2L plus 1, okay. That is total number of orbitals in the subshell. Yes, total number of orbitals in a subshell, total number of orbitals in a subshell, that is equals to 2L plus 1, okay. Total number of orbitals, that means M, okay. Total number of orbitals, that is equals to 2L plus 1, okay. You should remember that, that is very important. Total number of orbitals in a subshell, that is 2L plus 1, okay. Next, number of orbitals in a shell, that is N square. Number of orbitals in a shell, that is equals to N square, okay. So how many orbitals present in a subshell? In a subshell there are 2L plus 1 orbitals are present. But how many orbitals are present in a shell? In a shell means in a given orbit, how many total number of maximum orbitals are equal to N square orbitals, okay. And finally coming to the, what is the significance of magnetic quantum number? Like this, significance now, significance of magnetic quantum number, that signifies to explain orientation of suborbit. Okay, the orientation of suborbit gives the number of orbitals existed. Okay, orientation of suborbit. Orientation of suborbit. Okay, the orientation values represents what? Orbitals. Okay, that is magnetic quantum number. Okay, it is very simple and very much interesting. Okay, now coming to the spin quantum number. Okay, let us explain spin quantum number. Okay, spin quantum number was given by Uhlenbeck and Gaudsmit. Spin quantum number is given by the symbol S. Spin quantum number represents direction of spin of the electron in the orbital. Direction of spin of the electron, that means electron revolves in its own axis besides revolving around the nucleus. Electron spins around in its own axis and revolves around the nucleus. So for clockwise spin of the electron is given plus of, and anti-clockwise spin is given minus 1/2, that is minus half. For a stable orbital, the two electrons must have opposite spin values. For a stable orbital, the two electrons must have opposite spin values. Okay, that is about spin quantum number, right? So with this, briefly we can say that quantum numbers are almost completed. See, the significance of the four quantum numbers now completed. Okay, so what are the four quantum numbers we have? Principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Okay, the significance of all the four quantum numbers are completed, right?